कैसे ठीक है
क्या हुआ ये वाला चला
ये भी यूज
गुड आफ्टरनून लेडीज़ एंड जेंटलमैन। सबसे पहले तो मैं सब रिक्वेस्ट करूँगी कि सारे बैठ जाएं क्योंकि यहाँ कैमरा लगा हुआ है एंड वी आर गोइंग टू लाइव, सो प्लीज़ एवरीबडी सेटल डाउन। This is Maheen Akhtar on behalf of Association of Consulting Engineering Pakistan and from UIT. Before starting the event, I would like to welcome everybody who is sitting here and who is on live. Please scan this QR code for the attendance and then we will start the event. Okay, let's begin this session by seeking blessings from Almighty Allah. I would now like to invite our respected reciter, Mr. Awais, to recite a few verses from the Holy Quran to begin program on a spiritual note. Please.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. آمن الرسول بما أنزل إليه من ربه والمؤمنون كل آمن بالله وملائكته وكتبه ورسله لا نفرق بين أحد من رسله وقالوا سمعنا وأطعنا غفرانك ربنا وإليك المصير. لا يكلف الله نفسا إلا وسعها لها ما كسبت وعليها ما اكتسبت ربنا لا تؤاخذنا إن نسينا أو أخطأنا ربنا ولا تحمل علينا إسرا كما حملته على الذين من قبلنا ربنا ولا تحملنا ما لا طاقة لنا به واعف عنا واغفر لنا وارحمنا أنت مولانا فانصرنا على القوم الكافرين صدق الله العظيم.
Jazakallah khair for the beautiful recitation. May these verses bring peace, wisdom, and guidance to all of us. Ameen. Once again, I would like to welcome all of you here from ACEP, from UIT University, and to those participants who are with us on Google Meet, and especially FIDEC Asia Pacific. I would like to confirm that everybody please mark the attendance through this QR scan code. To formally start the event, I would like to invite Mr. Engineer Wasif Nazar Siddiqui, Honorary Secretary, ACEP, Board Member of FIDEC Asia Pacific, with over 20 years of experience in civil engineering, contracts and project management, a professional engineer registered with PEC. He has led major infrastructure, educational and industrial projects across Pakistan. Please welcome to deliver the welcome note and share the purpose of the organizing today's seminar. तालियां.
Bismillahirrahmanirrahim. Assalamu alaikum and good afternoon, ladies and gentlemen. It is a great pleasure for me to welcome all of you to this seminar on integrated MEP design for energy efficient and sustainable buildings. On behalf of the Association of Consulting Engineers Pakistan, I extend a warm welcome to all respected guests, participants, and students who have joined us physically, and all those who are participating online from across Pakistan and other countries. Today's session represents our continued effort to promote learning, collaboration, and professional development among engineers. I would like to express sincere appreciation to UIT University for the valuable support and partnership. We will be honored to have Engineer Suhail Bashir as our guest of honor, who will be joining us soon. From ACP, we are pleased to have with us our immediate past President, Engineer Arif Qasim Saab, and our council members, especially Fahad Hasan Saab, who will be our speaker today. The theme of today's seminar, Integrated MEP Design for Energy Efficient and Sustainable Buildings, is very important in the present time when we face challenges of energy conservation and environmental protection. MEP systems form the core of every modern building, and an integrated approach ensures functionality, comfort, and sustainability. It helps achieve better energy performance and supports the goal of green and smart infrastructure. Before I conclude, I once again thank UIT University for the arrangements of today's event, and I thank all participants for being with us. Let us continue to work together for a sustainable future and for the progress of engineering in Pakistan. Thank you very much, and may Allah bless you and our efforts together. Pakistan Zindabad.
Thank you, sir, for your kind words and for setting the tone for this meaningful event. Your efforts and leadership continue to strengthen the engineering community across the Pakistan. Now I would like to welcome Dr. Kashif Mahmood from UIT University. He is the Dean Faculty of Computer Sciences, double PhD from France in CS and BA Business Administration. Please come forward for the welcome note.
Assalamu alaikum and good afternoon, ladies and gentlemen. It gives me immense pleasure to welcome you to UITU for the CPD session. The topic is really interesting. I mean, I'm not an engineer by profession, but by heart I'm an engineer. So I mean, integrated this MEP regarding this sustainable buildings and energy efficient thing. We have been seeing a lot of energy crisis in Pakistan. We have seen that because, you know, this is something that is going to be there for quite a long time because of various kind of macroeconomic, evaluation that we do most of the time. Initially, we didn't had enough electricity. Now we have surplus electricity. We have, initially we wanted to have the solar panels. Now we don't want to have solar panels. So these kind of things are actually keep on happening. One of the most intriguing things that I find it's not present in Pakistan is because when you travel across different countries, you see green buildings. I mean, they are very hard to find here in Pakistan. So energy efficient buildings, less carbon, I would say environment friendly buildings, less carbon pollution and all that. And these things are all come handy with the SDG goals. So I think progressing on this kind of initiation from the PEC to have such kind of topics and people participating in such kind of trainings would be really very interesting. And again, one of the most important thing that we have been seeing in Pakistan is the deviation that we see from just having lectures, seminars, and by what is actually happening in the practice. So we tend to know a lot about the theoretical thing. We went to good seminars, good trainings and everything, but at the end of the day, when we go down to our tables and start designing the system, we always talk about the cheapest solution available, the low-cost solution that is available, the thing that could make us look a little bit more promising from the Pakistanis' point of view, but very, very critical and not environment friendly or energy efficient buildings. Unfortunately, one of the most common thing that I could see very easily in Pakistan from other countries is, like for example, when I was, I've traveled to more than 30 countries. I've lived across multiple countries, and to tell you the truth, whenever you go to a building, it's always very well ventilated and very well lit. You don't need electricity during the morning hours. You only require electricity during the evening hours when you need some light or something. And they always have been focusing on those energy efficient devices. Unfortunately, whenever we create or construct a building, I don't know why we construct a building in a way that there is not much light available even during the daylights. And that's why we have to use so much of the electricity during even the morning hours. So these are very simple things. I don't know what happens wrong with the architecture of the architectural discipline or something, but having coming down to the MEP level to have this energy efficient system would be something very I would be looking forward to. So welcome you all to UIT. I hope you would have a great learning experience at this session, and we would love to be hosting you again, inshallah. Thank you.
Thank you so much, sir, for your inspiring words. So we have so much future leaders among with us and great leaders. But we have Mr. Dr. Waliuddin here. So by your permission, sir, I would like to start the session. Okay, so now we move on the most anticipated part of this seminar. That's you guys are here, the interactive technical session on the integrated MEP design for engineering energy efficient and sustainable building. We are privileged to have with us Engineer Fahad Hasan. He is the director of YH Associate, a leading MEP consulting engineering firm. With over 25 years of experience in building design and construction. He holds a bachelor's electrical and mechanical engineering from UIT University, Karachi, a senior member and a great leader. Sir, please welcome here.
It's my honor to be here, and what Wasif bhai told me about this presentation that we are arranging a seminar here on integrated building design for energy efficiency and sustainability. So if you look at the title, it covers like 3 topics like the integrated building design, sustainability and energy efficiency. All 3 topics are collectively is a very heavy topic, And it's an advantage for me that normally when I'm preparing a presentation or this kind of seminars, so I'm trying to gather the data on that topic. But at this topic, the title is so vast that I have to deduct the topics. So I want to keep myself within the time limit of this presentation, and you would appreciate that I have tried to make a balance between the integrated building design, energy efficiency, and the sustainability, that rather than going into the basic definitions, I will try to emphasize on the process that how the integrated building design can benefit us in terms of the energy efficiency and sustainability of the buildings. The audience and the friends we do have, we have a blend of experience here. I saw so many seniors on the front seats with my fresh engineers and of the industry. So I try to make it in a balanced way. So if somebody have any question, we can discuss at the later, or if you want to make it interactive, we can make it during the presentation. So my presentation is here. Before I start the presentation, I must say Dr. Kashif Mahmood Saab have very briefly mentioned about the energy scenarios, what happens in the other regions. So recently we have done a regional conference about the energy by ASHRAE, and there was a speaker from Bangladesh, and he was consulted by himself, and he said in Bangladesh they have made 1,500 buildings green registered, LEED certified, either green or silver or platinum. In Pakistan, we have also done some green buildings, but we have a couple of dozens in terms of the quantity. So I asked one question from him that because Bangladesh is economy is better than us, definitely better than us. But when you are talking about the builder, he is least concerned about the environment and about what is good for the country or for the nation or the collective goals. He is more interested about his own targets and the financial goals. So he said there are the steps taken by the government and regulatory authority. They have make a rule that if some builder wants to have some like a green building in their premises or green features in their project, so they give him some discounts in the interest rate from the bank. Either it's for the buyer or if it's for the builder. So in that way, everyone is trying to get that green. So always it is not in favor of the buildings or in favor of the society that we go with the right way. All the time you have to give some advantages to the user if they are going to adopt it. So you have to give them some benefits. So it's like the collective goal. Definitely it is our responsibility as individual, but it is also again it's a larger commitment. It has to be from the government side. Sir, I start with my presentation. Basically, MEP cost for a typical building is around 30 to 50% of the total construction cost in a typical scenario, and 40 to 50% of the energy is consumed by the building. 60 to 80% of the energy consumed in a building is due to the HVAC. If we look at the residential building, definitely the power loads are not much because the cooking and the hot water business is by gas in Pakistan at most of the time. But your air conditioner is the main basically eater of your electrical consumption. But if you are talking about the office, so definitely the power requirement for the office appliances is definitely high. So we can say there the HVAC contribution is around 60%. So I go through a survey, and they said in Pakistan approximately 43.7% of the energy is being consumed by the buildings. So at an average, we can say 40% of the energy is consumed by the building. So an energy efficient and sustainable building is designed to minimize the environmental impact and the energy consumption throughout the entire life cycle from construction to the daily operations. When we talk about the energy efficiency, its features include the uses less energy, employs method to reduce the energy consumption for tasks like heating, cooling, and the lighting, which is very mandatory for the buildings. Otherwise, it will become like a dark cave. High performance buildings like high performance designs incorporates advanced insulation, high performance windows, optimal building orientation, minimize energy needs. Energy efficiency utilizes energy efficient HVAC equipment, lights, appliances to use less electricity for the same function without compromising the usage. Renewable energy often integrates on-site renewable energy sources like solar power to low dependency on the fossil fuels. And the sustainable features include eco-friendly materials, prioritize the use of recycled, renewable, and sustainable source materials to reduce the waste and demand for the new resources. Water conservation, definitely it is need of the day. Implement water saving measures like low flow fixtures, rainwater harvesting, draft resistant landscaping. Site integration uses features like green roof, wall to manage storm water, improve air quality, and provide insulation. Long-term thinking, consider the building's entire life cycle, aiming for resource conservation, pollution reduction, and adaptability over the time. Integrated building design, or IBD, is a collaborative process of preparing design and construction document that result in optimized project system solution. For IBD to succeed and be beneficial to the project. The entire project delivery team must be committed to understand and remain engaged and involved in the process from project inception through operation and maintenance time. Basically, the IBD offers the benefits such as reduced costs and time, enhanced sustainability, and improve occupant comfort and productivity through early collaboration and a holistic approach to the building systems. This methodology minimizes errors and rework by fostering open communication among all stakeholders, leaders, to a more efficient and high-performing and cohesive final product. Basically, IBD results project efficiency and cost saving, reduce conflicts and errors. Early collaboration between architects, engineers, contractors helps to catches and resolve the design clashes before construction begins, preventing cost reworking and delays. It saves time, a streamlined process, and proactive problem solving, keeping projects on schedule. Increased cost effectiveness, early coordination maximizes the synergy between the building systems, leading to a significant cost saving over the building life cycle. IBD also results sustainable and environmental benefits like enhanced energy efficiency. The integrated approach allows team to identify and implement opportunities for energy saving by having all systems work together effectively, such as automatically adjusting lighting based on the natural daylight system. If the complete team starts collaborating at an early date, definitely you can sit with the architect, with the planners, with the client, and convince them, okay, these are the advantages for the natural day saving, but advantages everyone is aware. But at the same time, the provisions you have to keep for the natural daylight saving based on the orientation of the building and the heights you require, you can implement at an early stage without making any extra cost on it. Maximizes green building solution. Early planning increases the opportunity to achieve aggressive sustainable goals and can lead to more lead points. Reduce environmental impact. The process can move beyond minimizing negative impacts to creating positive regenerative impact on the environment. IBD results occupants' well-being and comfort, improve occupants' comfort. Integrated system like smart lighting and ventilation can create healthier and more comfortable environment that responds to occupants' need, boost productivity, healthier and more comfortable environment, lead to improve productivity and well-being for the people using the building. It also results enhanced building performance, which is the ultimately results the energy efficient building, improves quality and functionality. A unified approach can lead to a higher level of detailed and more cohesive, functional and aesthetically pleasing design. Increase operational efficiency. The benefits extend beyond construction as it's the integration of the design facility more efficient and operation and maintenance throughout the building life cycle will happen. Improve safety and risk management. A comprehensive collaborative approach helps improve safety and manage risk more effectively. It's a ASHRAE assigned a task committee 7.1, which have done a lot of working R&D for the integrated building design. According to this task committee, there are several methods are possible for the project deliveries, like design, bid and build, which is very common in Pakistan. Another method is a design build, which is very common for the industrial projects in Pakistan. And design and construction management. Each method requires interaction between the design professional, representation inclusive of that project elements. What happens here in Pakistan and most of the parts, that there is a sequential design process which we follow. Like first the client will appoint an architect who will plan that area, make an schematic design, then they will go for the structural design engineer who will make the skeleton for that building, and then they come to the MEP engineers to develop what are the possibilities which can house within that limits. So the sequential design process is the process in which the elements of the building solutions are defined and developed in a systematic and sequential manner, and somehow called isolated. It's an isolated process. Although the complex buildings or the large size buildings, people have changed their strategy, and they cannot construct a high-rise building without involving the MEP engineers at an early stage, because you have to keep the provisions in that building, and it's commercially not viable, and also it is not practical to have a building without any MEP services provision inside that structure. So the steps, these steps, I have make a summary from ASHRAE TC committee. The architect develops the building program. The trade budgets are set to comply with overall project budget. This is the important thing in Pakistan, because whenever developer plans to develop a building, construct a building, they contact with the architect and they said, okay, how much space, square feet I can make on this building as per the laws, SBCA or cantonment of whatever jurisdiction is. So architect conveys them a number that you can construct 100,000 square feet or 200,000 square feet. They check at what cost they can sell it into the market, and they set their budgets. So that would be the land cost, that would be the construction cost, that would be the selling price in the market. So they have to keep it within that limit. Then the structural guys defines the skeleton of the building, as I said, and then the MEP service engineers are given the proposed layouts, and structure systems and trade builders then directed to apply the MEP solutions within that defined budget. Then there is the discipline design evolves on industrial path to support the allocated trade budgets. So again, everything has to be within that price limits and within the space limits which already planned for that area. So like the Dr. Saab mentioned about the most of the buildings he saw outside outside Pakistan, that they normally adopt the daylight savings and that kind of stuff. So if you involve the electrical designer or the MEP designer at an early stage, so definitely you keep provisions in your building where you can harvest the natural lighting. So these kind of advantages you can get in early date. At the later stage, if you want to have that provision that you have to redo the architecture work, you have to redo the at least structure design if you haven't constructed the building yet. But if you have constructed the building, definitely the cost would be like a fortune. The owner's project team then establishes the project program, including project scope and overall site plans. Contrary to this, the integrated design process execution of IDP requires a departure from the conventional SDP methodology. This change includes a true shift in effort during the classical design phases, schematic design, the detailed design, the construction document, but also includes the addition of enhanced effort outside the traditional design phases. Although the schematic design, the DD and the CDs will remain be there as a process, but the involvement of the stakeholders which you will involve in the project cycle at a later stage, they will involve at an early stage. And by the way, it is not only about the design, the end of the day, definitely somebody has to operate that building, that somebody has to maintain that building. So in the slides which will discuss later, it is also very important that the commissioning guys, the commissioning methodology has to be established at an early date, so that you must know your goal post. If somebody design a building like with a very great architecture features, with the very strong structure, with the very energy efficient MEP solutions, it's all on the paper, all on the documents. But the people who are installing it, they must be aware that what is the goal post for it. Rather than going for there, you write one thing, you draw one thing, they understand another thing, and the result will be in a third dimension. So the integrated design process is like that each stakeholder must give some input from the start of the project, so the project will be like it's a complete win-win situation. Design of a building services proceed through the phases like concept design stage first. No matter you are going with the sequential method or you are going the integrated design method, the first stage is the concept design, then the schematic design, then the preliminary design construction phase, and acceptance or the commissioning phase, that is handshake stage. In the concept design, the functional use of the building, owner and occupants requirements, architectural concepts, and the budget limitations are typically determined during this phase. These requirements should be documented in a statement of design intent for the building systems, which is refined and updated as the design progresses. If cold air distribution is to be considered for the project, it is the best to advance the option at this stage, so the entire design team can develop to the best realize its best fit. In the office buildings, in the commercial buildings, like if it is intended to be used as an office, it is very common that the builders or the project cost, you must say, limits you about the building heights. If you construct a building, typical office floor with a height of, say, slab to slab is 10 feet or 11 feet with some beams, so definitely at later stage it will be very difficult to introduce the ducts here. Otherwise you have to restrict the pupil that no one will employ any guy who has height more than 5 feet, because nobody will walk in that area. And sometimes what happens, I saw in the buildings, when especially in the buildings which are designed as a shell and core basis, the users or the tenants, when they arrive, most of them, like the high-end buildings, they go for the multinational tenants. And multinational tenants, like some banks or like corporates, they usually have their own standards for the health and comfort environment, their safeties and that kind of stuff. So they go for the, for example, there is an ASHRAE standard 62.1 which shows that beside the temperature, you have to maintain the environment, like the fresh air quantity, they define, the quality of the air, they define. So for that, you have to have the fresh air, which you have to treat first and then introduce to the area. To introduce the area, fresh air to the area, you need ductwork and you need the equipment to treat that air. So in a building, in a conventional building where you don't have the ceiling heights available to run the ducts, definitely you end up with the fan coil unit or the famous VRF unit, in which, or the wall mounted units that you may install at the wall. You cannot run the ducts everywhere. So it is very important to define the goals in the start, that what you want to construct. And even if you don't have the user at the start of the project, for example, it's a shell and core and you have, the client has a planning to give this building on the tenant or the sale, and the user may come to that project at the later stage. So it has to be like the elephant's footprint, like the modular kind of thing. Like the building must have the ability to have the capacity that somebody wants to add some defined system which is supposed to be in that area. Spaces would have to be there. This is the example which I have just discussed, like the reduced space requirement for the ductworks may allow revisions to the structure design. If you have plans to install the duct in an area where the structure is already designed, so definitely you have to do the redo. And if there's an integrated design approach, so that redos will be avoided. Otherwise, it will cost you in terms of finance, in terms of time. Similarly, it's a very interesting way of doing the air conditioning to the buildings, like the underfloor air distribution. If it is very famous in the cold climates, where you are utilizing the floor deck for the air distribution, your ducts are in the floor. In Pakistan also, in the several data centers, they adopt this method. So if due to any reason, if somebody want to adopt that, it has to be defined at an early date. Otherwise, you have to end up with the different levels of the floors. The concept design phase begins when the owner identifies the need for the project and the program is developed. The two end products of the program phase for the service engineers are the detailed design intent statement describing the selected system, and the second must have is like the commissioning or implementation plan outlining the process by which the system will be designed, installed and commissioned. As I said earlier, it is very important at the initial stage that you must define the goalpost for the building, that whatever you are designing, what the results you want to achieve from that system or the building. The design team performs a feasibility study to evaluate system options and establish a budget. At the conclusion of the concept phase, the owner selects the desired system and the design team produces a design intent statement. Before going into the detailed design, one must define at that where you want to go in terms of the finances, in terms of the timelines for the project. It may be at the concept stage, normally the 15 to 20% plus minus is pretty acceptable for most of the clients. So what we do normally, that if we know the building usage, the user requirements, so the MEP engineers normally develop plans, options which is viable for that. For example, there are 5 ways to do the air conditioning in that building, but 2 methods may not be applicable to that area or suitable to that building. That has to be defined, that the shortlisted are the 3 ones. All 3 options must have some pros and cons, like some option maybe have the higher upfront cost or but provide the energy efficiency, or some may have a short delivery periods and easy to install. Some may have easy to maintain kind of stuff. So that has to be put it on the table with some cost weightage, that indicative cost weightage, of course, because design is not there, so nobody can quantify, but some weightage based on the market practices or the market numbers and the experiences. So the client has an idea that in which street he want to land. The owner programs also includes the information to develop the design criteria, like the building area. Definitely at the start they discuss this with the architect: height, number of stories, geographic site locations, building construction material area and type of glazing and insulation levels, conceptual architecture drawings, function of each area in the building, occupancy and operating schedules, environmental requirements such as temperature and humidity set points, process loads, temperatures and flow requirements. The power requirements of the project has to be defined at an early stage. Life safety analysis, which determines the type of the firefighting system. We are living in an era where in our neighborhood and at our home, there is a race of vertical buildings, vertical construction, and beside vertical construction, the horizontal buildings are of larger densities. I remember when I have graduated 25 years ago, that time, if somebody has a project like 50,000 square feet or 100,000 square feet, and I'm not talking about my company, I'm generally about market trend. So it's like it was considered like a larger project in Pakistan. Today, sir, if you will randomly check with the architects, every architect is designing, someone is designing 50,000, 500,000 square feet area, 200,000 square feet area. If a normal building at the Jinnah Avenue, if they are constructing 14 stories, it end up with 600,000 square feet area. So the population, the densities of the buildings, the sizes of the buildings are such that earlier it was very like people don't consider firefighting or the live fire safety analysis, but today it becomes mandatory, because consider a building which is basically housing like around 2,000 people or 3,000 people, God forbid, something happens wrong. So it is not what system you have installed there or what is the buying power of that resident, if there is a bacha or is it like anybody inside that building. So you have to define that how they will evacuate that building or how they will stay in that building for certain duration safely till somebody from outside evacuate them. So life safety analysis is very, very important. There are standards for it, like NFPA 101 defines that what are the provisions you have to keep in the building. The civil defense is also doing a very extensive job these days, that they, before starting any incident, before happening any incident, one must prepare for it, that what will happen if, God forbid, if something happens wrong. So again, it is very mandatory. It is very mandatory. For the size of the building, you must consider the life safety analysis, which determines what kind of firefighting equipment, evacuation equipment, or the alarming equipment you have to install in that building. Water requirements of the projects must be defined at an early stage. Possibilities for the future growth and expansion. It is very important. It is important for the buildings which, other than the residential buildings, like if you are constructing a hospital, what happens? The structure is designed for 100 years. Life of the structure is 100 years. But if it is in a hospital, the my equipment or the MEP equipment life varies from equipment is 10 years, 15 years, and 20 years, 25 years is the life of equipment. Then you have to replace that equipment. Systems life, like the ducting and the other stuff you install in that area, may last for 50 years if installed good and working properly, handling properly. But altogether, beside this, the hospital equipment, the radiology equipment, the life of that equipment is very expensive equipment. The life of the equipment is 5 years or maximum 6 years. And if the equipment life is more, what happens? The evolution happens everywhere. The new researches and the new processes come. So they may require some changes in that area. So the possibilities of the future growth or expansion. The classic example, the computer arrived in Pakistan somewhere commercially early 90s. It becomes necessity somewhere late 90s. So the offices earlier, for the design offices which they have, like the design boards in the drawing section, they may have 3 or 4 draftsmen with fairly large size of the drawing boards placing there. Now every office where they used to sit, there were like 4 draftsmen. Now there are more than 10 CAD operators. This happens in my office too, by the way. So the density becomes, with the passage of the time, the requirements may change. So no one can keep the provision of 100% growth in that area or 100% modification, but decent or the known expansions must be kept in the provision. Acoustic requirements must be specified at an early date and must be handled. Applicable codes and standards are very important to specify that, because you must define your code at an early date. For example, we are living in a very interesting place that if you are working in Europe, so normally they go with the BS or CPC standards, or some RIBA standards are there for the design purposes. If you are going to America, they go with the NFPA or their ASME standards. NEC standard is there. So we are the location where this type of standard is depending not upon the authority or the local region, but depends upon the buying pocket. If your client has like a mindset or European origin, definitely he will ask for design the building on BS standard or CPC standard. But if you have a client or somebody like the donning agencies from American side, they will not ask you to design with design the system with NFPA. Americans will ask for the NFPA and they will ask for the CPC and that kind of stuff. So what happens, like one should define that what standard you are following, and it has to be consistently on some basis. It would not be like that 50% NFPA, 50% BS, and it was happened. I saw one specifications. They said, okay, for example, fire pump. They said you have to comply these 4 conditions of NFPA and these 3 conditions of BS. And believe me, when you go to the manufacturer, they are very clear on it. Okay, go for choose your side. Either you go with the European standard or go for the American standard. So it is very good to have that information with us that we are in the region that where we are using the European standard, we are using the American standard. But whatever standard used for a particular project, that has to be consistent. The reliability requirements, the budget for the capital cost and operating cost, and sustainability requirements. These has to be established at an early stage. Then the budgets are set at a holistic level, and the user requirement is set at a holistic level. Then the schematic design phase. In this phase, the designer selects and compares appropriate system to meet the building functional needs and develop the recommendations for the owner. This phase typically involves evaluation of the benefits and trade-off for the different design approaches. Annual energy consumptions, demand, cost, as well as system installed cost are estimated at this stage. The level of analysis may range from simple rule of thumb estimates to hour-by-hour simulation with detailed cost comparisons. It would be of your interest that most of my seniors must know about it, that when we talk about a building construction cost, for example, if it is costing you $10 per square feet. So if the life cycle, if you look at the life cycle cost, the rest of the $90 you have to spend for the next 20 years in the consumptions and the maintenance of that building. So at the early stage, if you are basically considering the life cycle analysis for the building, so you must be aware that what is the energy cost today, what would be the, you can forecast that what was the energy cost 5 years ago, so you can predict that what would be the energy cost after 5 years. So if you compare the life cycle cost, so you end up with a, you may end up with a conclusion that, okay, rather than spending $10 a square feet, you may spend $12 a square feet, but the saving of but the saving would be, rather than spending $90 in next 18 years, you may require to spend $70 and your system will be there. So definitely the system which may have higher first cost, but may be more suitable for that building. But if there is like a builder's project which they have to sell and they are not into the operations, so their intention would definitely be different, and practically it will be different. So they will not go, they spend even $12 is a big thing, they will not spend even $11 for that. So at the schematic stage, you have to make the cost comparison, and it is always better to compare the cost at the life cycle cost basis. After the schematic design, this is a preliminary design phase. During this phase, building service engineers coordinates the MEP system with architects, structure systems to resolve potential conflicts, to have a fight with them to get the spaces above the false ceiling or the openings in the slabs. Building light calculations are refined at this stage. Building power calculations are refined. Detailed load schedules are prepared. HVAC calculations are refined. Equipment sizes and capacities are selected at a preliminary design stage. System layouts are developed, and when we are coordinating with if it's say like a integrated design process for the project, so definitely you coordinate with the structure engineer at an early date that where your equipment will be, what would be the potential operating weights in that area, what would be the like shaft requirements, opening exhaust requirements for that area, and things will be in a streamlined way. Then the final design and preparation of the construction documents. In this stage, the primary layouts and the equipment selections are fully developed, and the final drawings and specifications are completed. Some projects involve preparing alternative designs with the bids for all options. In such cases, the primary options generally receives the most effort during the design phase. What I said earlier, like there are several options to meet the project requirements. Maybe somebody wants to have 2 options for their building, like there was an example in here we do have, like earlier we didn't have the gas connection for the residential buildings, so that time the buildings which were under construction, client normally keeps a provision for the LPG cylinder banks, and there are the companies who provide you the LPG gas along with the complete setup, and their Shazor came and they replaced that tanks, and they are charging for the LPG gases. So sometimes it happens that the design stage you are not sure that where you will be landed at the time of the construction of the after construction. So if you keep provisions, so you better make 2 designs or the alternative designs and go for the best one. Or if you are not like if there is a cost impact or the time impact, of designing two systems parallel, which is definitely two projects in one project. So usually you keep the elephant's footprint like provision for the both the the larger provision you keep in the design, so that it has to be like suitable for both the projects. I am talking about the space requirement, the water requirement in the underground tank, and the height requirements. Construction phase, the design engineer responsibilities during this phase typically include reviewing shop drawings, observing construction and conducting and witnessing the system performance test. Contractors may require guidance to ensure that, that they are following the project specifications rather than their own standard methods. Having said this, like what we are talking about, the integrated design approach, in this, your commissioning plan will be, you will develop the commissioning at an early date, and you may involve contractors to the certain extent, like opening of the provisions or the sleeves or the embedments in the building at an early date, but even then the contractor's main responsibility came at the later stage. But if you will involve their expertise at an early date, so what will happen, they are aware of the commissioning program or the goal post. So the projects like redo will be lesser at the later stage, and commissioning time will be safe. Acceptance or the commissioning phase or the shake hand phase. The term commissioning is often used to refer the startup and functional performance testing of MEP systems. Experience has shown that the comprehensive commissioning procedure is essential to success of a project. No matter what, how smartly you have designed the building, but it is important for the user. If I said, okay, I have installed an air conditioning system here, which is very energy efficient and gives you 50% of the power, reduce the power consumption by 50%. But if it is not maintaining the temperature of 26 degrees and maintaining 29 degrees centigrade, definitely the user will be say, what is, that will not be acceptable. So he is more he will be more comfortable with a mini split unit installed at the wall, looking inside the area rather than the ducts and the air devices which you install above the ceiling. So it is always important that commissioning phase has to be defined at an early stage, and the expectations of the project has to be designed at the early stage. It is a steps for the successful completion of a complex building project. Basically, I try to summarize it in a way that whether it's a new hospital, renovation of an existing laboratory, or expansion of a manufacturing facility, or a complex building in a complex buildings group like which has to design to perform at a high levels. It is not if it is not commissioned properly, the high performing facilities through was being built could be severely underperforming. In fact, a recent study by Lawrence Berkeley National Laboratory shows that in US alone, nearly 10 billion is wasted through energy inefficiencies. It's about not about us. We are definitely wasting much more than that if we would have the access to that 10 billion. So the leakages, the wastage of the energy is not like the consuming more power, but it is also the leakages in the systems, like valve leakage, the water flow leakages, the chill water flow leakages, air duct leakages, or improper control systems or sensing systems. We can save money and ensure that the complex building commissioned properly. For that, these are the 5 points. Begin the commissioning process during the pre-design phase or design stages. As I said earlier, that one must define the goal post at an early date, that what you are basically expecting from that design. Just because the bulk of commissioning efforts take place after construction completion does not mean that you should wait until then to begin commissioning. Commissioning, by the way, also involves the testing of the systems, but if your conduits are embedded, your pipes are embedded in the system, it will be very difficult at the commissioning stage to test them. So better start the commissioning phase at an early stage. The process should start as early as possible and be collaborative efforts among all key stakeholders in the building success, owners, architects, engineers, construction managers, subcontractors, and the building management guys. Make a clear plan, create a commissioning plan that defines the role and expectations of each stakeholders throughout the commissioning process. Most of the time subcontractors do not understand what they are expecting, what you are expecting from that system. They just do the commissioning, whatever you have make the written statement to them, and when you will checking that system, that you you will not be you may not be with the same page that this is what the design guideline says. So if you are involving the commissioning guys at an early stage, so everyone will be on the page and the commissioning method will be like more streamlined. In conjunction with the commissioning matrix can be developed that list all the commissioning tasks, who is responsible for their commissioning and the timing for those steps, providing a visual document to guide the process. The tasks identified in the matrix include procedures for review and acceptance. Requirements of the documents to be developed and approval of the commissioning plans to be defined. Schedules and inspection and the testing methods to be defined. Put it into the schedule, like if you have end up with dozens of the document, dozens of the method, but you must define it in the timelines. Whatever efforts you will put on that project, that has to be within the project timelines. No matter how good design you have made, what Einstein efforts you have put on that project, the client basically requires to complete their project within the defined timelines. Commissioning activities should be built right into the master construction schedule by incorporating the various commissioning tasks as line items in the master schedule. They are more likely to be completed in the proper sequence for the successful result. Adding commissioning to the master schedule also reinforces each stakeholder's responsibility over time and re-emphasizing the collaborative nature of the process by putting commissioning front and centers for everyone to see. The fourth one is the documenting each commissioning act, creating a log of performance standards, inspection, testing, and if necessary, corrective actions for systems and equipment. Verify that all relevant design and construction work meets the objective established during the pre-design or design phase. Detailed binders housing these commissioning logs known as turnover packages can then be created and maintained to serve as a historical record of the project. What happens that there are several, when you are construction activities are at site, there are several types of the test based on the systems and based on the components you do at site. For example, now it becomes very common that 99% you are installing this non-metallic pipe, UPVC pipe for the water supply system. Earlier we used to have this GI pipe. In US they are using copper pipes earlier. So now we are with the PPR mostly, or CPVC pipes. So the plastic pipes, when you are testing with the metal pipes, the time you test the metal pipe, it's very common and acceptable that whatever the working pressure in that pipe, for example, if you are using a schedule 40 pipe, the working pressure may be, your working pressure is maybe 7 bars. So you test the pipe by pressurizing the pipe with water for 1.5 times of the 7 bar or the 8 bar. You will end up with somewhere around 11 bar or 12 bar. So you will keep the pressure in pipeline by end caps and pressurizing the water inside it, and you will hold the water for 24 hours. If there would be no leakage, your test is passed. But in the plastic pipes, what happens, non-metallic pipes always have a memory that if it may pass your test, there is another method to test the PPR pipes recommended by the manufacturers and the standards. But what happens in the plastic pipes, that no matter if you are testing a pipe and if it will survive with that testing, maybe you put extra pressure and the pipe will remain there. And you will release the pressure and start using that building. Believe me, end of the day, the plastic pipes are like something, they have memory. If the pressure is meant to be designed, meant to be manufactured for sustaining 12 bars, and if you will apply 14 bar to that, and in case if it will not burst or rupture, and you withdraw the pressure, and next time maybe the same pipe, the same PPR may burst at 8 bar pressure, which is very lower than their defined range. So whatever testing you have done during the commissioning phase or in early stage, you must keep it documented that for the future, because the system you are installing, the installation time may be 2 years, the commissioning time may be 2 months. So altogether 26 months you have done, you installed all the new system and commission and everything working fine. But this system has to be operate for next 20 years or 30 years. So the maintenance team must maintain that system. They must aware that what you have done at an early stage. By the way, the pipe testing I have said, definitely if this kind of activity happens, somebody who is designing that pipe, he must say, okay, this pipe will not be installed and you have to replace the pipe. But end of the day, the user of the building, the maintenance guy, the operators, they will be the custodians of the building. They must know that what kind of system installed in their premises and what kind of testings happened with their systems. Sir. Sir, this I saw at one of the project that the PPR pipes, the method of testing for the PPR pipes, if you go for the DEDX or AGM or XYZ, any brand, there is a method of testing that pipe. They do not recommend, the BSEN do not recommend you to test it to hold the water for 24 hours in the plastic pipes. I believe I will share the details with you after this. They said you have to pressurize the pipe for 5 hours to a certain pressure. Then you have to increase the pressure of the pipe for next 2 hours, and gradually you have to increase it. And then you release the pressure. This is the way they recommend to test the plastic pipes, the PPR pipes, because they are the polymer pipes. Huh? So if you put the extra pressure on it, so definitely their strength may be affected. Sorry? Definitely it has to be done by the recommended practice. But what I saw, I am not with the group who say, okay, put it on the pressure for the 24 hours. But this is normally happens in the projects what I saw in everywhere. So what happens that my point is not that how to test the pipe. Definitely I will go with the. Sorry. Excuse me, please. Okay. Can you hear me, sir? Okay. What I was saying, sir, okay, whatever component, pipe, material you are using for your system, so first of all, you have to follow the standard method of installation. You have to check that what is suitability for that area when you are selecting the material, and that you have to test the pipe according to certain standard, what you said. Like for the metal pipes, definitely you have to pressurize it for 24 hours and you have to test it and do it. But for the plastic pipes, it is always recommended to follow the another way of testing it, which is like defined in the standard. So you have to test it accordingly. But what happens in the projects where you do not have the proper consultants there, proper team there, there plumbers somebody have. So these plumbers are very smart guys, and we learn a lot from the people who are actually installing it at site. But what happens, they have 40 years of experience. They may say, okay, since last 20 years I am using the testing of the pipe by this method, I will test this method. They will pressurize the pipe and most of the time it will work. But what manufacturer says, if you are basically exposing the pipe at a higher pressure than the design rating, they withdraw their warranties. If you will share that document with the pipe manufacturer, they said, okay, no warranty will be there. So it is, you are very right, it is always, you have to check within the defined parameters which is meant for. Train the operators to ensure consistent building performance on ongoing basis. It is essential to train the facility staff and management team regarding the correct operating procedures for all the systems installed. This effort can include one-on-one training from the equipment manufacturer, vendor, or the controls contractor, as well as producing the manuals and the video support programs, which is very common today. At the end, I would like to summing it up, although not all a comprehensive list, but these 5 steps are counterstand for a good commissioning process. The effort helps assure owner that the project will be successfully completed within scheduled parameters in terms of cost, in terms of time. The facility is fully functional at first occupancy. We have done a project here. I'm not basically like, it's not commercial. I'm just sharing it like an engineer that I feel proud on it. What happens when you are commissioning a building, you require 2 to 3 months to commission the system there. Like sometimes temperatures are out of order, sometimes your parameters are out of order, then you commission it. So we have developed a mall here, and in that mall, before starting the mall, 2 months ago, the client says, okay, I wanted to start the system. There's a cost with the fuel cost and the system of power consumption. He said, no, I don't want to have the embarrassment at the later stage. I want to operate it. So they have started the mall, and within a month, we have commissioned a mall without occupancy. The small size was around 6,000 ton. The air conditioning capacity was 6,000 ton, and 100,000 square feet, 1 million square feet covered area was there. But that size of mall was commissioned not because we are champions, but because the strategy we adopt there, we sit with the client and clearly said, okay, this size of the mall will require time. You have to adjust the things, and it may take months if something goes wrong. So they employed the right people on board, the commissioning guys, the contractors. We keep all of them on board. We make a schedule, and we have commissioned that building 2 months earlier than the starting date. So if you are planned, your client has targets. They have spent, by the way, a lot more amount on the operations to operate that system for 2 months. But if somebody has plans, it was his target that he wanted to start everything fine at the first date. But some people may say, okay, if I will constructing a mall, day one occupancy will not be 100%. Even in 2 years, if the occupancy will be 50 to 60%, it is a successful model. So again, you have to clearly mention with the clients, these are the timelines, these are the bases required, and this would be the like costs in terms of man hours, or in terms of like finances or the fuels. So you have to collectively discuss and then implement it. And then the building optimizes energy efficiency to reduce the operational cost. Facility managers and maintenance personnel are fully trained and engaged, creating a better chance that ongoing maintenance is managed, reschedule system, downtime, expenses, and so on. Like I said, at the time of the commissioning, you may end up with 19 or 20 services, in MEP services in the building, which will start from the air conditioning with the CCTV, low current system, and the water system, and you name the system, it will be there. So you may end up with 50 or 60 brands, equipment of different types installed in your building. Every manufacturer surely gives you some warranty for the year or 18 months. So with that guarantee or the warranty, they give do's and undo's. So that has to be clearly defined in a one operation manual, and the team who is basically responsible to operate all that systems, they must aware that this is the operational procedure, this is the SOP to operate the air handling unit and the generator and so on, and the pumps. And beside that operations, just like we do with our vehicle, like you have to check it, tail pani of this oil and replacements and this kind of, and the maintenance has to be made. Like the air handling units, you have to check the filters periodically and check it. And like the motors, no motor, you all know that will not burn at once. It starts misbehaving, like the ampere it is drawing, it will start drawing higher ampere, the noise of the motor will be changed much earlier than the finally goes off. So if there is systematic periodic maintenance, then the things will be, you can predict the maintenance schedule, you can adjust the things much earlier at your convenience. A safer, more comfortable environment is created for the workers and the guests. There will be less miscommunication throughout the construction process. There will be fewer chances of errors there. So this is what I have developed, and the main idea I was trying to discuss here is like we all are aware about the energy efficiency in Europe, in America, in the developed economies. It is like a what you call it, it's like a fashion kind of thing, or their commitment towards their nation kind of thing, but it is mandatory for us because we don't have that resources with us. Buying power is limited. So if you are basically designing something with energy efficient equipment, or your system is consuming lesser energy, so definitely you end up with a better system. But the key idea is, if you are planning to, if you are So you are saying something? Acha. The central idea is that if you are planning to have a building MEP systems with low energy consumptions, energy efficiency of course, and sustainability, so it's not about you as a designer or you as an engineer or the contractor. It has to be like a project defined goal, and it has to be like the client and the buying pocket must be aware that this is the goal he wants to achieve. If I don't know any client, any person who is basically developer or the constructing a building, and you will say, okay, you want energy efficiency or you don't want energy efficiency. Everyone wants energy efficiency, but if you want to have the energy efficiency, then you have to basically you have to select the path which leads you towards the energy efficient solution. It may require the more timeline, it may require more timeline, may require more finances or more some expensive equipment there, but it has to be defined at an early date. This is the first thing. The second thing which I try to convey here is like everyone has a role. Like the architect normally starts, the builder definitely will not publish in the newspaper and uh, bring a like a dozen people there who will install the equipment, who will supply the equipment, or who will the structure. Definitely he will contact the architect. But once the project is started at this stage, you have to involve the professionals at an early date, rather than constructing a building and then you think, okay, I want to finish the building and I want to put the systems in, then you have lesser choices in your hand. So if the decision of selecting equipment or defining the systems, MEP systems of the building will happen at an early date, so definitely you have to engage the people at an early date, and the commissioning process has to be defined at an early date. So in that way, you will save the time, you will save the finances, and definitely things will perform how it was supposed to do. So sir, this is all from my part, and I request you all, I hope you understand if you want me to repeat something. Thank you very much. And if somebody wants to have, if somebody wants to add something here, which I may miss, so he may discuss. If somebody has some question, I am here. So I am open, sir.
One of your slides, you mentioned that commissioning should be start prior to the designing. How it would be possible? Because
No, commissioning plan. My point, my plan is commissioning plan. Yani you must define that if you are going, for example, you are going to install a still water system, so you must define that this kind of checks I will do and this will be the activities I will perform. It's a document, it's a planning. Arvai.
When we're talking about the energy efficient building, and there is a role of building management system also.
So true.
You haven't commented on that. Can you put some light on that? That how efficient it can make a building, IBMS.
Very good question, sir. Sir, we are basically living in an era where Internet of Things, IoT, is very common, and surprisingly, our new generation, the smaller kids are more smart on these kind of gadgets than us. But as far as the building IBMS is concerned, we have designed several buildings with IBMS, but it gives you the advantage, two advantages. One is the system is basically operating at the optimized mode, because if you have a chiller plant, for example, with air handling units, definitely you go with the end of without BMS, you will have the standalone system. Chiller plant room have their own controller. The air handling units individually have their own controller, and they are operating on the localized parameters which they are measuring from the duct inside room thermometer or the pipe sensors. In the BMS, you collectively getting all the data at one place, and you are at the position that you can choose the options that which scheme gives you more energy saving. I have done a project in Pakistan where the system was installed, but BMS system was not installed. They had like 15 years old chill water system in that building. It's a multi-story building, and they are planning to install it. The intention was not the cost saving for them. normally we get cost saving by BMS system installation by optimizing its operation. But the intention was to have the preventive maintenance or to get the signals before it goes fail. So they connected all the air handling units and the chiller plant, the lift, their pumps, their water tanks, their tank levels, lighting, and to the certain point. They make modifications, major modifications in their controlling system, and they are get benefited of it. We have done a mall in which the client was basically, it was a IPP. They had the gas connection earlier, and they are the license to produce the electricity, by the way. So they make the analysis that we go for the hybrid chill water plant. The electric operated chillers are way efficient than the old age absorption chillers. But the gas price they had that time was like more economical for them to operate it, to operate it and produce the chill water by the gas operated. So they make a 50-50 kind of arrangement, like in the daytime they operate one, then in the night time they operate other, based on their load, because the night time they had more load because of the lighting, so their absorption chiller starts working and they make the cogeneration and produce electricity for that. So they make the hybrid model. So you very rightly said, if you have in a building with IBMS or the building management system, definitely the result is not ending up giving you the data log sheets, but it enables you to set a sweet point or the very optimized point for the operation of the building. And the added advantage with the BMS system is, like, it gives you the signals, like as I said about the motors, that no motor will burn out at once. It's not like the heart sees ho gaya, bad gayi. So it's like it starts misbehaving, the ampere parameters will be abnormal or the noise will be abnormal or something happens wrong much earlier than certainly stop of that. So if you have the BMS, so you can measure or monitor all the parameters and can manage your facility in a much smarter way. Arif?
I was seconding you that I must have designed about 500 or 600 buildings, no?
MashaAllah.
Yeah. So most of the time, no, the people are late in utilities, no, MEP. They have the structure constructed and everything, no, but the utilities are not there, and they get late on starting the whatever the factory or whatever they are.
So
no?
true.
This is happening always, no,
So
90% time. So integration is very important.
It is.
Yes, I just wanted to support it. No, actually, the architect always says, no, to do it, no, but the owner say, oh, देख लेंगे यार, अभी तो बहुत देर है, अभी क्या करेंगे, and it lingers on, no.
So true.
When my turn will come, I will speak on it, because as a member of the Sindh Building Control Authority, 2 years back, MEP is the most neglected part in the Sindh Building Control Authority.
We are the neglected child.
They look after for the architectural approval, architectural submission, structural submission, structural vetting,
So true.
but no consideration of MEP.
So true.
So 2 years back, we, with Abad and all other stakeholders, we developed a document so that it also become mandatory that during the approvals, Arif Bhai knows well, I think Ashkar was DG at that time. We completed all the document and we submitted it to the, for the legislation. But somehow the Abad people thought that it will be another problem for them to get this clearance, and they stopped it. That document is ready. What we wanted is that we feel, as an engineer, we feel that Karachi is the showcase of the failure of plumbing projects. Whenever you are traveling on a road, you will see all buildings leaking, because as Arif Bhai said, builder said that, okay, dekh lenge, baad mein ho jayega, whatever. And the structure is okay, building is okay, but the plumbing is worst, and it ultimately leads to corrosion of the reinforcement also by leakages and all this thing. So probably we together with the ACEP also on board should take some measures and should try to convince the authorities to bring the change in the local bylaws of the Sindh Building Control Authority. Whatever you talked is for very true for high-end buildings, but what about the medium and low-end buildings? That there is altogether a missing
The
element
larger
of
volume is
MEP.
there. You are very right. No, Swelba, you are very right that the major volume is like not the high-end buildings, it's like 20 or 30% buildings where the client is aware, or they are in a competition where they want to have they have the buyer which is a higher price. But most of the time your major business from the market where the builder's client is from a very competitive market and they have to sell according to in the comparison. But believe me, the cost of plumbing, you aware of it, is nothing but the peanuts if compared to the total cost of the project. It's like the unawareness or something like what you call it, like ignorance kind of thing, that people are least concerned about these kind of things. And Arifai rightly mentioned that it's not the buildings which fails. It's always the plumbing systems. Most of the time you have the leakages there. If you drive through the Shara Faisal, the client, the builders, the developers have developed very decent facade and elevation and kind of stuff. But every building every user starts installing the outdoor AC units at the periphery, at the front. If the builder has control on the building, he only restrict, okay, do not install at the front side, keep it on the side view. But the issue is not this, the issue is what my friends said, like, if you will not keep the provision in the building, so end of the day the user will not say, okay ji, I will not I can live with low light or with a high ambient with high temperature in the building. Definitely they require some requirement in the area. The second thing is about the plumbing and the electrical and plumbing always happen at the project that the builder says, okay, no, ye to hamara banda hi khud hi kar lega. He knows this, how to do it. You know better than so many people.
Okay, I would like to add in right now. Here,
This is fun.
Safwan. I'm an electrical engineer by profession and as well as a design consultant. For those who do not know me, one thing that I would like to point out is that another element that sort of tends to get overlooked, especially with buildings in general, not just energy efficient building, is the interconnectivity of the utility supply with those buildings. Unfortunately, most of the laws, the bylaws that are in practice today are only for what is known as the horizontal interconnectivity, supply of power to these buildings. They do not take into account the vertical elements of the building in terms of, that is why most of the time we find ourselves challenged and fighting a long-standing war with the utility companies, where their bylaws state that the metering system has to be located on the ground floor, while we are now designing buildings which are exceeding beyond 50 floors now.
So true.
And as per basic requirements, when you're talking about power distribution, you need to do a decentralized power distribution systems where you need to have multiple sort of distribution centers where you supply the power to residential units, apartments, or other load centers. There is no concept whatsoever for how to cater those kind of requirements in the current bylaws. Those need to be addressed as well. Those need to be identified as well.
Very right.
And as one of the point that you mentioned, that electrical, in terms of connectivities and all those, tends to be like, ye mera banda dekh lega, sab kuch ho jayega.
It happens.
That is one of the worst scenarios where we end up getting solutions which end up certified to be failures. And one more thing that also needs to be looked at is how our utility companies tend to determine the power demand requirements for a building. We are still, the calculations that are being made are based on the assumptions and estimations that were developed in the 1960s, where the building load is still determined based on a 10 watt or 15 watt per square foot plus air conditioning and those kind of frameworks. Whereas right now, when we talk about ASHI, we talk about green and energy efficient buildings, our power consumptions are less than a watt now. But
So
still,
true.
this is something that needs to be looked at as well. Thank
Very
you.
right. Thank you very much, Safan, for adding it. What happens that we are the nation with very tough muscles. Tough muscles are like rigid muscles, or what you call is like a stone. We always done the things in a difficult way. There was a blessing in disguise. By the way, I'm not like happy what I'm discussing, but what happened, there was a fire incident happened in recent years in Pakistan, specifically in Karachi, and before that incidents, normally people do not install the firefighting systems, even if there was some requirement from the code or from the insurance falas. So they said, okay, you design it, I will install it at the later stage. But the incidents, the unfortunate incidents happened in Karachi. Then what was happened? Globally, whenever something goes wrong, there was a professional body who investigated. But unfortunately, in our region, SHO makes a FIR and he investigates the engineer. So in that, after that incidents, people are start basically going to adopt that system. So I believe not today, but in the coming years, definitely things will go better. And the second thing is, I'm very positive about it. By the way, it was a joke or I'm serious about it. But what I saw in my practice that 10 years ago, the sizes of the building, as I said earlier, was small. It's not about that you are doing, me doing, or somebody else is doing, or what kind of client is. No matter what system they are installing, it's a high-end building or an average building. The densities of the buildings are such that nobody can go with the conventional practice in that system. The vertical building starts constructed in US just because of brakes they have invented for the lifts. It was not lifts. Lifts were invented 17th century, but it was a safety they have invented for the lift as a brake. Then they have started going vertical. They have increased the footprints just because of the air conditioning and the ventilation, mechanical ventilation. They have developed the systems for that. So the densities of the buildings we do have definitely in coming years, or the buildings we are designing today will not be functional with the conventional system. So definitely about the authorities, the electrical authority, the KE, I believe they have allowed in some building the vertical connection in the meters in Karachi. In Punjab, the LESCO, they have already approved this. So they are basically transforming it. Yeah. So true. So true. You are very right. Thank you.
Sir, I want to add sarcastically one thing. I have seen many buildings in Karachi. They have emergency exits in case of fire or any emergency, but all the exits are locked, so people don't go from there. So this is the thing we are living in.
Unfortunately, sir, मैं आपको बताऊँ आपको ना, Ferrari is we are developing an economy. Ferrari is very good car, but you know it's an 80-20 Pareto rule. Like 80% of the finance is in the hand of 20% people. So if somebody has finances, if they have the liberty, he imports a Ferrari in Pakistan, and what will happen after 6 months? Definitely he will park somewhere at the road or at his garage, because he will not get the mechanic here unless he will arrange some mechanic from outside and the spare parts from outside and maintaining his car. So the issue is, it is no matter how smart system you have designed, how best equipment you have installed, or the supervision you have made and the commissioning efforts you have done on the project. The most important thing is the operator of the building, the user's commitment, the owner's commitment, that how they are using it. Whatever, the vehicle is a classic example. No matter what quality of vehicle you do have, but if you will not maintain it, definitely it will end up somewhere at the road. So you are very right. You are right. Mike. You are very right. You are very right. But what happened? We are in the same trap. We learn it in a difficult way. God forbid if some incidents happen or somebody, not incident happened, somebody is facing problem in some circumstances. So that buildings becomes like the value of the building becomes decreasing. I don't want to mention the name, but there are some commercial buildings at Shara Faisal. they do have the central air conditioning system, they do have central firefighting system, and they do have very good location, by the way, with ample parking. But believe me, with the passage of the time, their value is decreasing because they are not maintaining that building. It's not about the temperature or the lighting they have maintained in their building, but they are not maintaining the safeties and that kind of things. And people are not like the early days. They are very clear about their requirements. We have done a mall in Hyderabad, and believe me, the outlets, the indigenous outlets, these guys were way aware about the firefighting system, about the air conditioning system, and they asking for that, do you have the chill water, do you have for the sprinklers and that kind of stuff, and how they are operating it basically. Because your name is there, they have 30 branches and the 40 branches in the nationwide, and nobody want to have the bad tech with his name. No? So awareness is basically developing in the country, this is what I can say. Sir. Mike.
Business community to run this integrated MEP design, sustainable and.
I would request, can you repeat please, because.
Okay, I just wanted to know that what kind of coordination is needed for a business manager and architect and an engineer to implement this integrated MEP design for sustainable.
Okay. As I mentioned in this slide, it's like since my childhood, these are the stages which we all aware, like the concept stage and the schematic stage and the primary stage and the construction and commissioning phase. What this integrated building design offers or requires at the initial stage, the involvement of all stakeholders or the professionals on board. If you are developing a multi-story building, you can say it's an apartment building, very simple building, apartment, lower floors you may have 2, 3, 4 parking, then you have a ground floor at the lobby and few shops, and then you have the typical apartments upstairs. So there are two ways of doing the thing. Now, appoint an architect, he will mark the layout, view that 3-bedroom floor, 2-bedroom floor, this much floor at flats at one floor, apartments at one floor, this is the corridor and this kind of thing. Then you will appoint the structure wala who will put the structure design and make the beams and the structures and the columns. They may coordinate with the architect, adjust the things, and final. Then you start thinking that I need the light there and I need the plumbing engineer there. Definitely the architects, we do have the structural engineers, professional structural engineers, we do have, they all know about the requirements. So they keep the provision for the tanks, they will keep some provision for the shaft, that there I will provide the shaft. Definitely if you are contacting RFI or the Suhail by, so you will not basically, they will not design the system without keeping the provision for the shaft. Because they are the engineers, they know this will come later. But they keep the provision. But at the start date, if you will keep the MEP engineers on board with you, so they will specifically define you that this would be the shaft requirement there, because otherwise it would be like the elephant's footprint, or it may be the shorter, it may become shorter. So the MEP guy will give you their input that this is the specific size required at this place, or this is the option. Secondly, as far as water is concerned, water tanks we normally keep for the 2 days storage. So at some locations, the client says, no, I want 4 days storage. You keep that 4 days storage. But at the early date, if the client has a pocket and a commitment for the water conservative building, like the sustainable building, so he say, okay, I want to have a low flow fixtures in my building. Low flow fixtures costing you 2 times or 3 times the cost of the normal fixed faucet. If your bathroom plumbing mixer set, indigenous come 30,000 rupees, the low flow fixture will cost you 120,000 rupees. So that delta he understand and he multiply with the quantity and he say, okay, this is the extra amount I want to pay, but because of low flow fixture, your per person demand will be reduced. I am not asking to compromise on the firefighting demand, but somebody is clear that, okay, I want 4 days storage rather than 2 days, but I will use the low flow fixture, so this is the total quantity. Maybe both will end up with the same number, maybe some different number. But in that way, the client has a very clear understanding, everyone on the project has a clear understanding that this water reserve apparently looks like instead of 20,000, 25,000, but it is meant for 4 days storage just because they are implementing the low flow fixtures in the building. So these kind of strategies are very easy to implement at an early stage. Like air conditioning system, normally this is a magic number which I don't agree and most of the professional engineers not agree, is 150 square feet per ton. Every shop wala will give you the sale the unit like the window unit and the split into 150 square feet, 1 ton de do. So what happens that if you are calculating the building load properly and you end up with like 2 tons or 1 ton installation is there, you are at that position, you haven't constructed the wall yet. So you may check with the, you may work out that if the wall is south facing, you may add insulation there, you may put double glazing there. So you end up with a 70% of the air conditioning capacity, your install cost will be reduced, your footprint will be reduced. So my point is that at an early stage, the concept stage, if you will keep the stakeholders on board, so definitely it will end up with a better return. Thank you very much.
Thank you so much, sir. Thank you so much for the insightful and knowledge-packed session. Thank you very much, and thank you all of you for the interactive session. Before wasting my time, I would like to invite our guest of honor, Mr. Engineer Suhail Bashir Sahab. He is a civil engineer with over 30 years of experience in engineering, procurement, contracts, and HSE implementation. He holds advanced degree from NAD University, currently serving as CEO at Saita Pakistan Private Limited. He is also chairman at the Institute of Engineers Pakistan. Please welcome to share your valuable thoughts and closing reflection on today's topic, sir.
Bismillah ar-Rahman ar-Rahim. I start in the name of Allah, the most merciful, the most beneficent. First of all, thank you, Fahad, for a wonderful presentation. Where is he? Okay. I think in our, again, I talk about the middle and low side construction industry. This is the most neglected part in those buildings. Arif Bhai is involved in SBCA for a very, very long time. And I think 2-3 decades before, there were good builders like Memar, Hassan, Rimpa. If you see their buildings after 30-40 years, still you will find no leakages, excellent maintenance, because at that time they thought it fit to invest not only in structures, not only in finishing, but also in plumbing. Unfortunately, this is a missing element, and you can see a building constructed 2 years before and leaking. And when you travel on Rashid Minas Road, even when you are coming from airport, the moment you turn on the Sharaf vessel, you will see lot of buildings which are leaking, and which is really a very bad impression for all of us as a nation, that what we are doing. Secondly, he mentioned about M, E, and P, and mostly Fahad remained on M. Little bit he brought some E, but I am for P. P is for Pakistan and P is for plumbing, and that is very important. 2 years back, I visited the ASHRAE headquarters at Atlanta, and I saw the HVAC plant there. It looks like an hospital, that plant. So clean and so beautiful that I couldn't imagine that an MEP plant could be like this. I have worked for good 25 years with K Electric, and I have seen all the plants. I was the project engineer at the Bin Qasim power plant, and I've seen a lot of things. But still, that was, and again, recently visited China and Korea. And there also, they have invested, because 10 years back, they were not like as of today. But now they have changed all their design methodologies, execution methodologies, and now they are at par with any industrialized country in Western, in Europe or in America. So we need to have that thing very soon. That is a real requirement, and as I said, that we tried 2 years back to bring this MEP as a law for the Sindh Building Control Authority, and that is still lying with the legal fraternity, probably ACEP, IEP, and I am also member of, Arif is also member of the Sindh Building Control Authority. We can try, and especially we need to educate our builders, the new builders, that this is not anything which is develop another policing method for the SBCA, but this is good for all of you. So if that happens, and very rightly, you very rightly pointed out that MEP professionals need to be involved since inception. They are not that everything is completed, the structure is completed, आजा भाई मेरी बिल्डिंग की बिजली की लाइनें भी डाल दे और प्लम्बिंग की लाइनें भी डाल दे और प्लम्बर तो मेरा 30 प्रोजेक्ट करा चुका है, 31वें में क्या प्रॉब्लम होगी? This is the normal thinking of हमारा काका भाई बहुत ज़बरदस्त है, वो करता है. This is the way they are doing. But they do not realize that उनके पिछले 30 projects were a failure. Yes, they handed over in a beautiful सुर्खी पाउडर बहुत अच्छा लगा देते हैं, मेकअप बहुत अच्छा कर देते हैं, लेकिन internally they are deficient, and ultimately the people who are the users, they face problems. So I think a wonderful presentation. Thank you to ACEP, all ACEP professionals for bringing a very important topic, and I feel that these things need to be also addressed with the Abad people, sit with them, give them presentations, bring them these professionals there and show them that it is cost effective, because उनके पास तो आखिरी चीज़ है पैसा कितना बचेगा, रोकड़ा कितना बचेगा, ये वाली बात है. So it is cost effective. You see, there are two terminologies used. एक है कि preventive maintenance, एक है breakdown maintenance. We all believe in breakdown maintenance. We don't do for preventive maintenance. Preventive maintenance is very important to survive, to have a longer life of the project. With this, I conclude, and I thank all of you for your patient hearing. Assalamu alaikum.
Thank you so much, sir. And thank you for this very good session. And now we are moving towards to call Dr. Muhammad Waliuddin, Professor Dr. Waliuddin. He is the renowned academic leader and researcher currently serving as Vice Chancellor of University, UIT University, Karachi. With over 23 years experience, he has led multiple universities, including Sir Syed University of Engineering Technology, and holds a PhD in electrical engineering from Northern East University, United States of America. He has authored 75 plus international publications in control system and signal processing. Dr. Waliuddin has received several prestigious honors, including the Governor of Sindh Gold Medal and IEP Lifetime Achievement Award 2025. Sir, we request you to kindly come forward and share the closing note. Thank you.
Bismillahirrahmanirrahim. I will not talk about the topic because a lot of discussion has been made. So, first of all, I congratulate the ACEP for organizing this session. It's a wonderful session about the topic. And as pointed out, that if we go along any road, even in the posh areas like where I'm living in the Clifton, the same problem which is highlighted. We have another building which is developed, it's about 32 storied next to our apartment building. And it's like 2-3 years back, and the things are starting leaking from that building. So that's the problem, and that's we have to find out the solutions for it. So organizing these sessions, highlighting the issues, that is the main thing of the. It's a work of a university. Do the research, point out the things, have the policy involved in the policy making. So that's why we always welcome any organizations which want to hold such type of sessions and have the dialogues with different stakeholders. So we welcome them to and give them our platform so that university play its role. It's not just about imparting the knowledge, it's about involving in the policy making. having some impact on the society. So first of all, thank you for choosing this UIT University for this wonderful session. Definitely, Fahad Saab has given a lot of food for thought for all of us, especially definitely the seniors are here and also the juniors who will come and play their important role in a few years. Once they are planning, they are looking at the different things. I just wanted to highlight, we have started one simple project of an auditorium. If you go down and you will see, it's a very small auditorium. And we have faced these issues from the very beginning. So we have involved MEP consultant from the very beginning. Once we are designing, we have chosen one of the architects, renowned architects. And from the very first day, we have started engaging the MEP consultants. And we have finalized, we have changed the HVAC, we have changed the lightings, we have changed the electrical systems. Definitely plumbing is not there much. But the ideas they have given, and we have changed the design 2 to 3 times based on their, because of the HVAC, we have previously the different type of HVAC. Now we are having a higher tonnage AC, and because of the height and so on. Similarly, now we have the different structures for all the seats with the different gadgets available on them. So there, what we have seen is that it was very useful to involve them from the very beginning. So this is a very small project. So definitely if you are making a huge project and you are not involving them, definitely it was a really mind shocking for me that they are involved at the last stage. Most of you are sitting here, have so much experience, and definitely you are the policy makers and you are implementers. So, so for me, it was like, why they are not involving them? Because it's a very important part and parcel of any, even for the small projects and definitely for the brigade projects. So thank you once again for all the participants over here and live for joining us today. And inshallah, the platform is available for any type of such event for any future. If you want to engage us for any of the things, you are always welcome. Thank you.
Thank you so much, sir, for motivating your words, for gracing this event with your presence. As a token of appreciation, we would now like to present souvenirs to our distinguished speakers and guest speakers from ACEP. Now I would like to call our guest of honor, Engineer Suhail Bashir Sahab. Please come forward. And I would like to call Mr. Arif Kazim Sahab, Wasif Nazar Sahab, and Vice Chancellor of UIT University, Waliuddin Sahab. Please come forward and present the shield to our guest of honor, Engineer Suhail Bashir Sahab. Now I would like to request our guest of honor, Engineer Suhail Bashir Saab, to present shield to the Vice Chancellor of UIT University, Dr. Waliuddin Saab. Thank you so much, sir. Now, I would like to call our speaker of this seminar, Engineer Fahad Hasan, sir. Please come forward. There are some souvenirs from UIT University. UIT University presenting souvenirs to our guests and speakers. First, Engineer Suhail Bashir Saab, Chairman IEP. Can someone please come here to volunteer this? Engineer RF Kazim, immediate past President ACEP. Please. Engineer Wasif Nazar Siddiqui, Honorary Secretary AACEP. Please, sir. Engineer Fahad Hasan, please come forward. Director YH Associate and thank you. Before we disperse, we would love to capture this memorable event. So I've asked, please take a group photo of speakers and guests. Okay. Okay, thank you all once again for being a part of this informative session. We hope you had a valuable experience. If you want to attend more learning sessions like this, so please follow the pages of UIT University and ACEP. Thank you very much. Have a wonderful evening ahead. I would like to request to all the participants, please go outside for a photo, group photo, please. All the participants to please go on the stair sides for a group photo, please.